Today on How It's Made Dream Cars, Germany's iconic sports car, the Porsche 911. The city of Stuttgart in Germany is known as the cradle of the automobile. It's where the Porsche family designs and assembles some of the most recognizable sports cars on the planet. 3,000 employees work to build the company's most celebrated car, the 911 Coupe. In 1963, Ferdinand Alexander Porsche designed the first 911. It was originally called the 901. However, an existing model from a competing car manufacturer meant that the car had to be renamed the 911, and it's been in production ever since. The car is the result of a long history that stems from the 1939 Type 64, a model with an all-aluminium chassis, whose final version never emerged. Porsche considers it the grandfather of all their cars. Since the beginning, the company has created sports cars, and cars specifically for motorsport. The latest model is the most sophisticated version of their classic. Underneath the familiar body shape are advanced technologies and improved engine performance. It's a car based on tradition, innovation, and with a racing heritage. Production begins with the body shell assembly, where the chassis is made from mild steel and aluminium. Production islands with weld and transfer robots put together the largest parts, notably the base of the engine bay. The 3 robots are programmed to work on all variants of the model. The quality of the spot welding is checked, and after each weld is inspected, any necessary changes are made. The distance between the parts are also measured to certify that there aren't any variations greater than a few micrometers. Once the inspection is completed, robots move the parts to another workstation. The car's body shell side panels move via a conveyor lift to a welding station. The panels are loaded into the robot, which then welds the parts into place. Since the car's chassis is a monocoque structure, the side panels are attached with the base already complete. Automated guides hold the panels in place while they're welded to the base. The body shell assembly line delivers the doors, and weld robots secure them by welding the hinges to the body. However, it's only temporary, as the doors will be removed after the painting process to be reattached on the vehicle assembly line. Other frame parts and the car's roof are welded to the vehicle platform in this automated assembly section. Once complete, a lift moves the skeletal body to another station for treatment and inspection. Here, the strength and quality of the welds are inspected and verified. Afterwards, the structure is taken by an overhead conveyor lift to another assembly line for parts and cleaning. At this stage, the bonnet is installed, and then the body is cleaned. Using special cleaning agents, any construction dust along the body's surface is removed. The frame, weighing 36 kilograms less than the previous generation chassis, is moved by a transfer lifter to the paint shop. The painting process begins by dipping the body into a bath of cathodic dip primer. Cathodic paint enhances the corrosion resistance of the car's structure. Next, a high-pressure shower rinses the frame to remove any excess paint before the frame dips into the primer treatment again. The body shell is dipped into 7 consecutive primer baths, ensuring it will be completely protected from rust and other environmental damage. By flipping and returning the body into the bath, This guarantees that the primer paint reaches every cavity and corner. It also eliminates any streaks that might develop at the joints. After the paint is cured in a 30-minute drying procedure, the structure moves into another room. Here, robots underseal the seam with sealing paint, which consists of a PVC coating. This layer of protection waterproofs all the seals and helps prevent corrosion. In another paint room, the body receives a filler coating. Robots apply a base coat that aims to protect the body from stone chips. The filler coating colour is selected by the customer. The car receives 8 layers of the environmentally friendly water-based filler coating. Once that paint is cured, the body shell moves to another area where robots apply 2 solvent-based clear coats. Wearing protective gloves to avoid any contact with the new paint, the company's crest is then installed onto the bonnet using a specially made clamp, revealing a symbol of Stuttgart's pride. Hidden beneath that familiar silhouette is a 6-cylinder engine that produces 400 horsepower and enables the 911 to reach 100 kilometers an hour in 4.5 seconds. The production of the engine begins with pre-selected engine components such as the crankcase, the crankshaft and pistons. A rod connecting machine is used to assemble the piston rods to the piston heads. A leak-proof ring surrounds each piston head. Then the combined unit is gently slid into the cylinder block of the crankcase. Once all the pistons are set, the cylinder block moves to a new workstation. With the aid of a lifting device, the crankshaft is lowered onto a work table. Using lubricated clamps, the connecting rods are installed and fastened to the crankshaft using an air impact screwdriver. After securing the piston rods, metal timing chains are added to the crankshaft. Because it's too heavy to handle manually, a mechanised lifter is used to lower the crankshaft into the casing of the crankcase. After it's attached into position, all moving parts are checked to ensure they're working. As the 2 separate cases of the crankcase roll into a containment room, transfer robots raise one part onto the other. The 2 parts are aligned and linked. The 6 pistons are now parallel to each other in 2 rows of 3. The new engine block is then moved onto a carrier called a cross-member, which transports the engine to other stations for further assembly. At the next station, a cylinder head gasket is installed onto the engine block, in between the 2 housing parts. The cylinder head section, which houses the camshaft, is then fastened into place with an air impact wrench. Then the engine block is rotated and a second cylinder head gasket is installed on the other end of the engine block. Next, another large piece of the engine block is lowered into place using a lifting device. Large bolts are then placed into specific positions. Then the near-complete engine is sent to another workstation for further parts. The cross-member automatically takes the engine block to this next workstation. After the double overhead camshaft is complete, a robot installs and fastens a cover. Each screw is tightened to a precise torque setting to avoid any unnecessary tightness or damage. The entire engine assembly rotates and it's set to a new position before entering a cabinet for a cold test. This assessment device checks the new engine with a leak test, flow test and pressure test by simulating its function using an automated air pump. After testing, the main part of the engine is complete. Next, the intake manifold is fitted, followed by the exhaust manifold, which completes the assembly of the 3.4-litre six-cylinder engine. At the end of the line, the motor is transferred to a robotic cart, which takes the completed engine to be fitted into a 911 on the assembly line. Today on How It's Made Dream Cars is a car made in Germany, the Porsche 911. We've seen how the body and engine are built, and next is the car's interior. In the upholstery department, coloured leather is chosen according to the customer choice. The cowhide is sourced from certified cattle herds and is placed on an optical scanning table that also removes any wrinkles. Within seconds, a high-definition camera assesses the leather's size, holes and marks in detail. Using a special mouse, any defects are marked and the area is traced for further recognition. This eliminates any imperfections and is essential to cutting the leather into pieces. The leather from 5 cows are needed to complete the car's interior, and during this process, 40% of it is discarded. Once complete, a code is placed on the hide to identify which piece is which during the next process. The leather is then spread out on an automated cutting table. The identification code is read, and the leather will be cut into pattern pieces. The computerized system ensures all the pieces are cut accurately. The pieces are cut out using a very small EcoJet, which sprays water at a high pressure of 18.3 kilopascals, ensuring that the leather isn't damaged or torn. Any residue or remains are removed, leaving behind the pattern pieces sliced by the EcoJet leather cutter. To avoid damaging the material, white gloves and a spatula are used when each new piece is placed with the others to send to the sewing room. Using industrial sewing machines, the pieces of leather are then stitched together using high-strength thread. The thread colour can either match or contrast the pigment of the leather pieces. Next, the leather is infused with a high-strength glue. It's placed into a casting unit along with the upper part of the dashboard. A pressing device is then lowered which fuses the two parts together. To ensure the leather is properly fitted, the material is pulled smooth on all sides so that the seams match the frame. Next, finishing tools are used, such as a directional heater, to make sure that the leather is bonded to every part of the dashboard frame. The dashboard is then placed into a special kiln, which will dry the adhesive and bond the materials completely together. Once dried, the unit travels to a new workstation. Here, a rear plastic panel is placed onto the inside of the leather-clad dashboard. An automated cover contains the area, while a bonding device fixes the parts with fastening ties. The shape and construction of the upper dashboard means that installing the car's dials and switches is easy. The fully upholstered dashboard is then partially equipped, and then using a mechanical lifter is installed into the car's cockpit. The car's body moves along the vehicle assembly line, protected by vinyl coverings. And without the doors, interior installation work is much easier to execute, such as fitting a glass sunroof. Two window assembly robots are responsible for the installation of the front and rear windscreens. The first robot applies an adhesive paste around the glass edges. Then the second robot gently places the window into position, using infrared sensors for accuracy. Robots then move the car to the next level of construction, all of which takes place within the same building. The Porsche 911 engine, gearbox and axles are fitted by a synchronous elevating platform, where the parts are inserted into the body. Customized options are also installed at this point. First, the gearbox is fitted to the 3.4-litre six-cylinder engine block, ready for the next stage. Both parts are then lowered using a hoist onto a workstation where systems including the drivetrain and suspension are added. Next, the exhaust system is attached and aligned. Raised and transported by a suspended conveyor lift, the car's body is slowly lowered to ensure that the engine block and dampers and suspension slide directly into their design slots. Commonly known as the marriage of elements, the drivetrain and chassis are then bolted to the body of the car. Next, the car's bumper is carried and fitted to the rear of the car. Using a special preset mold, the nameplate is then added to the car's rear bumper. A simple adhesive and finishing roller keep it together. The car now enters the final stations of the vehicle assembly line. Using a lifting device, the tyres and rims are mounted onto each wheel plate. The company's assembly planning uses the cost-effective just-in-time strategy, which avoids keeping the various parts overstocked. At this station, the car regains its doors. Next on the production line is the fitting of the car's leather-clad bucket seats, which are installed into the cockpit using a special lifting device. After body and electrical adjustments on the vehicle assembly line, the car will undergo a series of tests. The car is driven onto test rollers. Computerized laser sensors scan labels on each wheel and monitor their movement, checking for alignment and balance. At another station, the wheels are manually shook laterally to check the axle alignment. Sensors and computer software help with the adjustments. Next, the direction and focus of the lights are checked. The car is then driven onto another set of test rollers. In this test, while the accelerator is pressed, a device called a dynometer records motor performance, measuring the power and torque output of the engine. A water leakage test uses mid-pressure showers, while leaks are searched for in the cockpit using a torch. When the extensive tests are completed, the car is ready to exit the plant. The factory in the Zuffenhausen district of Stuttgart, Germany, produces more than 40,000 cars per year. Twice the amount it did during the early 90s. Only variants of this and one other model are assembled here. But instantly recognizable and originally engineered for the racetrack, this car still attracts attention, just as it did in the 1960s. However, the interior has developed substantially over the years, and the original flat-six engine produced just 160 horsepower, which has more than doubled with the current 3.4-litre version. Although a large departure from the first 911, the car still retains a lot of the original styling, which has been updated aerodynamically. But ultimately, form always follows function for this car manufacturer. However, over 50 years ago, when Ferdinand Alexander Porsche first set pen to paper to design the original 911, did he ever envisage that his car would endure and be a true motoring classic?
New for Animal Planet next. It's not just the budget that's out on a limb in Treehouse Masters. Here on Discovery, the battle's on for a Studebaker president in Texas Car Wars.